Alright, this lesson is on the slope of a line. Let's start with just drawing any old line here. And let's say that we have 2 points that we know that are on the line. We'll put 1 point here. We'll say that this one is at x1 or x sub 1, comma y sub 1. And we have another point on the line, let's say up here at x sub 2, comma y sub 2. If I go straight across from here to here and then upwards, the vertical distance here is y2 minus y1. If we had some numbers, we could calculate this distance. This is known as the rise. It's the change in the y value. Change in y. This here is known as the run, and its distance is x2 minus x1. This is called the change in x. Change in x. Now the slope is, they use an m to represent slope. The slope is the ratio rise over run, or change in y over change in x. Or another way, this is known as the slope formula now. Slope formula. It's y2 minus y1 over x2 minus x1. That's usually the formula we use to calculate the slope of a line, assuming that you know 2 points of the line. Let's do an actual example of using this slope formula. Find the slope. And let's say we know that our line goes through the 2 points, 2 comma negative 1 and negative 5 comma 3. And I can even graph these, though it's not necessary to actually calculate slope, but it helps some people seeing a picture. Let's plot those 2 points. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, 2, negative 1 is right about here, and negative 5, 3 is right about there. Those are our 2 points, and our line would look something like that. Not the straightest line, but that'll work. Okay, let's actually use the slope formula here. The slope formula was y2 minus y1 over x2 minus x1. Now you have to pick which is going to be your x1, or x1, y1, which point is your x2, y2. And it doesn't matter as long as you keep the 1's together and 2's together. I'm going to make this the x1, y1, and this will be the x2 and the y2. I always recommend that you use parentheses first in place of the variables. That way you can avoid any mistakes with negative signs. Because that is probably the most common mistake here, is somebody missing a negative sign. I'm now going to plug in the numbers in the correct place here. Let's see, y2 is our 3, and y1 is negative 1, and x2 is negative 5, and we've got x1 is 2. Okay. 3 minus a negative 1 is actually 3 plus 1, which is a 4, and negative 5 minus 2 is a negative 7. And so working this out, our slope is negative 4/7. When a slope is negative, that means your line heads downward to the right. If I start at this point up here, what this slope means is that my rise is negative 4. In other words, I go down 4. 1, 2, 3, 4. A rise of negative 4. And a run of 7. And so I run 7 across this way. And so my slope is negative 4/7. Let's try another one. Find the slope. And the 2 points that we have for our line are 1 comma 2, and 8 comma 5. Our slope formula is y2 minus y1 over x2 minus x1. I will make this my x1 and my y1, and this will be my x2 and my y2. I'm now going to plug in my numbers in the correct place. This will be 5, that's a 2, this is an 8, and that's a 1. 5 minus 2 is 3, 8 minus 1 is 7. And so this line has a slope of 3/7. Let's just check and make sure here. Let's see, I need to go 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. 1 comma 2 is right here. 8 comma 5 is right about there. It's an estimate. Our line looks something like this. And so our slope of 3/7 tells us that if we start here, we are going to rise 3. For rise of 3, 1, 2, I guess 3 would be about there. And then a run of 7. Run over here, 7. So rise over run, 3/7. Notice that if your slope is positive, then your line heads upward to the right. Here's another one. Let's actually start with the line. Let's say I know that our line here goes through the point 4 comma 0, and up here, let's say this is 0 comma 3. And so our line looks like this. And I want the slope of this line. Find the slope. Well, I do have 2 points. I could use the slope formula, or I could actually just use the graph. As I did before, how would I get from this point down to this point? I would start here, I would head down 3, so that's a rise actually of -3. And then I would have to run this distance, which would be a 4. Since this is the rise and this is the run, the slope is rise over run. This line has a slope of -3/4. If you want to use the slope formula, we can do that. I'll make this my x1 and this my y1. This is my x2 and this is my y2. So if I plug in the numbers in the correct place, I would end up with, let's see here, this is 0 minus 3. This is a 4 minus 0, and that is going to simplify to -3/4, which is the same slope that we got up there. Okay, so that's how we use the slope formula. Let's do a couple of special cases here. Let's say we have a line that is horizontal. And let's say we know it goes through this point, which is at -2, 0. I'm sorry, -2 comma, we'll make that a 3. -2 comma 3, and over here it goes through the point 1 comma 3. Let's use the slope formula and find the slope. I'll make this my x1, I'll make this my y1. This will be my x2 and that'll be my y2. Now if I plug in the numbers into the slope formula, let's see what we get. We get a 3 here, we get a 3 here, and then a 1 minus a -2. That's a 0 over 3, and then 0 divided by 3 is 0. The slope of our line is 0. And this is always the case of horizontal lines. Something that you should just remember. Horizontal lines, their slope is always 0. For any horizontal line, slope is always 0. Now what about a vertical line? Let's take a look at that. Let's say I have a vertical line here, and let me put in a couple points that it goes through. Let's say this vertical line goes through the point, let's make this 4, 3, and this point here would be 4, -2, let's say. I'll use those two ordered pairs to find the slope. Let's make this our x1 and this our y1. This is our x2, this is our y2. Plugging our numbers into the slope formula. -2 minus a 3, then we've got a 4 minus a 4. That's -5 divided by 0. And -5 divided by 0 is not 0. From what we learned back in, I believe, chapter 1, division by 0 is undefined. So we would say here that the slope is undefined, undefined slope. You cannot say that the slope is 0, that is different. All vertical lines have undefined slope. Some books say they have no slope, but I'm going to use the term undefined slope. So what have we learned here? So far we've learned how to use the slope formula, and we've also learned that horizontal lines always have a slope of 0, and vertical lines always have an undefined slope. Alright, moving on. Let's graph the line, and the information that we have is the line has a slope of 2/3, and we also know that it goes through the point -1, 4. Okay, and so we use this information to graph our line. Let me put some marks here. 1, 2, 3, 4, 5, 6, 7, 8. All right, let's start by plotting this point right here. -1, 4 would be right about here. 1, 2, 3, 4. -1, 4. Now the slope, if you recall, is rise over run. So what this slope is telling me to do is to rise 2 and then run 3. From this point, -1, 4, I'm going to rise 2, so I'm going to go up 2, 1, 2, and then I'm going to run 3, and you always run to the right side. 1, 2, 3, which put me right about there. If you want, you can repeat this process. From this point now, I could go up 2 and over 3. If you're careful, you can even go backwards. Let's see, from here I could go back 3 and then down 2. And you could keep going and going. The points that you come up with should line up, and we can then graph our line. Each one of these little triangles I've drawn is a rise of 2 and a run of 3. Alright, so we've graphed our line. Let's try another one similar to this. Let's go with this one. Graph the line, and we know that it has a slope of -4, and we also know that it goes through the ordered pair 3, 1. Let's start by plotting this point, 3, 1, which would be right around here, 3, 1. Now the slope is -4. We want to think of slope always as rise over run, and so you need it to be a fraction. So I'm going to think of the -4 as -4 over 1. Let me write it down here for you. if the slope is negative, I always make the negative sign go with the numerator. I never put it in the denominator. That way I know that I'm going to rise -4, which actually means go downward, and I'm going to run 1. If you always put the negative sign with the top, you will always run to the right. You'll never have to run to the left. Okay, so from this point, 3, 1, I'm going to rise -4. That means go down 4. 1, 2, 3, 4, about there. And then I'm going to run 1, 1. And that would put me right about there. I could go backwards if I want to get an extra point up here. Back 1, and then I would then go up 4, put me about there. And our line should look something like this. There it is. The rise is -4 and the run is 1. Keep in mind that a line which heads upward will have a positive slope. A line which heads downward to the right will have a negative slope. Oops, let me fix that. A horizontal line will have a slope of 0. M equals 0. I guess I should write that. That's the way your book would. Slope is 0. And if you recall a line which is perfectly vertical, its slope is undefined. Undefined slope. Now, if you take an equation and you solve it, or a linear equation, and you solve it for y, you get what's called slope-intercept form. Y equals mx plus b. It's called slope-intercept form. When the equation is solved for y, this number in front of the x, the coefficient of the x, is the slope. And this number on the end, which the book calls b, is the y-intercept. The y-intercept. So if I give you an equation, a linear equation, you can find the slope of the line simply by solving the equation for y. For example, find the slope. Let's say we have the line, we've got the line, I'll make one up here, 2x minus 3y equals 6. Okay? And I want the slope of this line. Well, if I put it in slope-intercept form, I can find the slope. I'm going to solve this equation for y. Subtract 2x from both sides. Negative 3y equals negative 2x plus 6. Then I have to divide everything by negative 3, of course. Divide everything by negative 3. And let me write my answer up here. We don't need to graph this one. And we'll end up with y equals, let's see, this is going to be a positive 2/3 x, and then this here is actually a minus 2. Okay, there it is in slope-intercept form. The number in front of the x right here is the slope. And so I know that the slope of this line is 2/3. The slope is 2/3. Let's try another one like that. Let's see, find the slope. And the equation here is, let's say we have the equation x minus or plus 2y equals 5. Okay, we want the slope of the line. I'm going to put this equation into slope-intercept form. I'm going to solve it for y. So we'll subtract x from both sides, which will give us 2y equals negative 1x plus 5. And then we divide everything by 2. Divide by 2, divide by 2, divide by 2. Y equals negative 1/2 x plus 5/2. Alright, there's our line in slope-intercept form. And this number right here is our slope. So our slope is negative 1/2. A couple other ones. I think I can squeeze it on the side here. Find the slope. Let's say you have the line y equals x plus 3. This one's already solved for y. It's in slope-intercept form already. You just have to remember that the number in front of the x is actually 1. And so this line has a slope of 1. Compared to this line, y equals 3. Now you have to recall that y equals 3, notice it has no x's in there, is a horizontal line. And if you graphed it, it would look something like this. 1, 2, 3. It's a horizontal line like that. And we learned just a while ago that all horizontal lines have a slope of 0. And after all, I guess you could think of this as 0x plus 3. The slope of this line is 0 because it is a horizontal line. And of course, if you have something like x equals 3, we of course recall that that is a vertical line, which would look something like this. Vertical. And we learned that all vertical lines have a undefined slope. Undefined slope. Okay, next. Parallel lines. Let me fix that. All parallel lines have equal slopes. So it's very easy to tell if you have parallel lines or not. You compare their slopes. Sometimes you want to know if your lines are perpendicular. All perpendicular lines have slopes that are what are called opposite reciprocals or negative reciprocals. Examples of negative reciprocals would be if one slope was 2/3, the opposite or the negative reciprocal of that, you got to flip over the fraction. You also have to make the opposite sign. So 2/3 and negative 3/2 would be negative reciprocals of each other. Another example of that would be the opposite or the negative reciprocal of 5. Since 5 is really 5 over 1. The opposite reciprocal of that would be negative 1/5. And if you have, let's say, negative 1/2, the opposite reciprocal of that would be a positive 2, or 2 over 1. Okay, so those are negative reciprocals of each other. So knowing this, we can answer a question like this. Are the lines parallel, perpendicular, or neither? And let's take these two lines right here. 2y equals 3x minus 6, and the other line is 2x plus 3y equals negative 6. To tell if they are parallel, perpendicular, or neither, all we've got to do is compare the slopes. So that means I've got to solve each one for y. So let's take this first one here. I just have to divide everything by 2. Y equals 3/2 x minus 3. This one over here, I have to first subtract 2x from both sides. 3y equals negative 2x minus 6. Divide everything by 3. And we end up with y equals negative 2/3 x minus 2. Okay. So this one over here has a slope of 3/2, and this one over here has a slope of negative 2/3. And it looks to me like those are opposite or negative reciprocals. And from what we just learned, that means that these lines are perpendicular to each other. Perpendicular lines. Let's do one more. What about these two lines? (2x minus y equals 4) and 4x minus 2y equals 12. Okay, so let's see if these lines are parallel, perpendicular, or neither. Solve each one for y. Subtract 2x from both sides. Negative y equals negative 2x plus 4. Got to divide everything by negative 1. Like that. And we end up with y equals positive 2x minus 4. Alright, so there's one line. Next one, subtract 4x from both sides. Negative 2y equals negative 4x plus 12. Divide everything by negative 2. And we end up with y equals, that is a positive 2x minus a 6. Okay, each one is in slope-intercept form. Looks to me like each one has a slope of 2. They have equal slopes. And so that means that our lines here are parallel. They are parallel to each other. Okay. And I believe that ends our lesson here on slope.